In this video, we're going to be doing an intro to polynomials. The main reason I'll be doing this video is because the next video and the next maybe 7 videos after that will all be about quadratic equations. And a quadratic equation is a type of polynomial, is a second order polynomial. So let me just quickly write a quadratic equation here. Plus 3x minus 4 I think will work. That'd be a simple quadratic equation, something we see a lot of in second level mathematics. They're very important, and if you're doing exams in this subject, you're going to see a lot of them. Okay, so first I'd like to just do a quick introduction to polynomials. And to help me with that, I have four little questions here. What you'll be learning in this video will be how to multiply brackets out, something I already expect you to know, but a quick recap never hurts. We'll be multiplying brackets out again, but with different letters. Just want to show you that different letters don't change anything. These could be A's, B's, X's, Y's, anything. Another one that's just a little bigger, just to involve more terms. It doesn't have to be just x squared. It can go up to, this one will go up to x to the power 5. And the last one here, equating polynomials. So that's a little different. We'll talk about it when we get there. While I have this up here, I might as well just write this little introduction. Second order, first order, and zero order. So these are all order. And this is what a polynomial is. I should have really prepared for this. And we'll write polynomial here. So a zero-order polynomial is basically a equation, or doesn't have to be an equation, doesn't have to have an equals. It could just be a group of terms. A zero-order polynomial is just a number, 7. It has x to the power of 0. There's always x to the power of 0 after anything you want. Why would you write it in? But that's a zero-order polynomial. A first-order polynomial might be something like just an x, or maybe an x with a number. Both of them were. Or maybe an x with a number with added another number onto it. They're all first-order polynomials. Basically, if it has an x to the power of 1. Again, we don't write the 1. That's a polynomial. Here's a second-order polynomial. That is that, x squared minus 4. They're both second-order polynomials. If I put a number here, 2 plus 1, that is also, that doesn't look great, does it? So we'll say 3 minus x squared. That's also a second-order polynomial. Basically, the biggest x in it is where you get your information. The biggest x is 1, first order. The biggest x, the x to the most powers, maybe I should say, is 2, second order. The x to the most power is 0. There's no x there. There's 0 x's. And third order would just be x cubed. Again, with any number, any other terms, 2x squared. For example, here's a third order polynomial. Okay, I didn't really mean to go into that much detail about that, but that's where this naming comes from. Polynomials go on forever, and they're quite useful. I won't get into their uses. Later on in the course we'll talk some about them. Just for now, they can everything can be put into a polynomial, pretty much. So if you have something that's really complicated looking, you can, what's the word I'm looking for? Approximate it using a polynomial. They're not always great approximations, but third and fourth order polynomials are actually really, really useful. But we'll talk about that much later in the course. Okay, for now, let me just do some of these. I'll go quick enough because I expect you to know a lot of this already. Question 1, multiplying out brackets. I'll write it again. We've already mentioned this while I've done them. You just multiply everything on the left, everything on the right. Keep a close eye on question 3. We'll see it again. Everything on the left, everything on the right has to multiply. So in this case, we have 2 terms and 2 terms. We should get 4 out. 4 terms out as an answer. X by x is x squared. X by minus 3 minus 3x. 2 by x is plus 2x. 2 by minus 3 is minus 6. Again, something I've expected you to know already, but now I'm just going to state it more explicitly. We can add or take away like terms. So when we look at a formula like this, we ask ourselves how many x squares there are. We can add them all together. They're all like each other. And there's only one of these terms. This is a term, 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 term. Anything split by a plus or a minus. And we ask ourselves, there's only one x squared. So we add them all together, we just get 1x squared. X is a bit more interesting. There's 2 of them. These can add together. It's basically, think of it as 2 apples, you owe 3 apples. You eventually owe 1 apple. X squares, think of them as oranges, but they're different. It just happens. That's very confusing because in this case, then an orange, two squares multiplied would make an orange. So maybe I shouldn't say that. The x squares are distinct from the x's in this case, and all the numbers then are just minus 6. That's our answer. That's how we multiply our bracket. Let's do number 2. Plenty of room down here to do it. We have a squared minus 2. No difference that they're x's or a's. They're just something. We multiply this out. Everything on the left, everything on the right. Just happens there's only one thing on the left. 1 term, 2 terms, 1 multiplied by 2. We should get 2 terms as an answer. A by a squared is a cubed. A by minus 2 is minus 2a. Add all the like terms together. There are none. All the there's only 1 term with a cubed. There's no terms with a squared. There's only 1 term with a. There's no terms with numbers. They're all alright together. That's our final answer. Just so you know, this is a 2nd order polynomial. This is a 3rd order polynomial. I realise I'm from Ireland, so when I say the word third, it sounds funny, but 3, 3rd order, polynomial of order 3, might sound better. So there we go. Let's move on to the more interesting ones though. Number 3. So this one's not that interesting, it's just bigger. Let's see, x squared plus 2. Oh, sorry, I forgot to say, you maybe should have paused these and tried to do them yourself. Too late now, I'm afraid, but not too late for this one. Give it a little pause and see if you can do this. You've seen how it's done with simpler ones. Right, we have 2 terms on the left, 3 on the right. Ask yourself, how many terms would you get as an answer? 2 multiplied by 3, you will get 6 terms. Everything on the left has to do everything on the right. There's 2 here, so there's 6. We're going to get 6 things out. So let's start. X squared by 2x. We get 2. 2 by 1 is 2. 2 x's by another x is 3 x's. X cubed. 2x cubed. Okay, let's go a bit faster. X squared by x cubed is x to the power of 5. We will do an entire class, an entire video in the future, and maybe I'll start linking these around like a web perhaps, or maybe I should have done this video before now, of how to multiply powers. I haven't done it yet because these are the simple ways, these are just the simple rules, and there's much more complicated rules to do with dividing and fractional powers. For now, I think we've all seen this already. X squared by x cubed makes x5. But we'll talk more in a future video. Okay, x squared by 1 is x squared. 2 by 2x is 4x. 2 by x cubed is 2x to the power of 3. 2 by 1 is plus 2. Now ask yourself, what order polynomial is this? The answer is 5. The biggest number, basically. The biggest number with an x. These are all pluses. Ah, well. Now we'll add some like terms together. Always start at the biggest. You don't have to, but it looks better. Or if you want to start at the smallest, that would look fine as well. But we tend to start at least in Ireland we do. That might be different in different countries. X to the power 5. Let's check for all of them. No, that's the only one, so we write that down. X to the power of 4. No, there's none of them. X to the power of 3. There's one and there's another. What have we got? 2x to the power of 3's plus 2x to the power of 3's gives us 4x to the power of 3's. Okay, x squares. Just one. X's. Just one. And numbers. Just this one here. That's our final answer. That's how you multiply out those brackets. Big, messy. Often we'd like to leave it like this for lots of questions. If I had it equal 0, I'd love to leave it like this. But sometimes we like to multiply them out. Okay, so that's our final answer. Like I said, polynomial of order 5. Let's see. Now the last one is a little more interesting and not something you would all need to know. It'd be more of a higher level piece of information. But I won't write it out again. It's just, well, maybe I will. You know what? I don't need any room to do this. So I will actually put it here. This is not going to be difficult. I can write it again down here. 2x. Ask yourself what you think the answer might be. I expect you to be able to get A, B, C, and D. Which, that might confuse some of you. I hope it does nearly, because some of you might ask yourselves, did I not say in the previous videos, one equation with one unknown? That's what we need to solve. And in this case, you don't know x, you don't know A, you don't know B, you don't know C, you don't know D. There's 5 things you don't know in one equation. So how are we going to solve this? A very useful piece of information is the x cubes on the left will equal the x cubes on the right. Like terms will equal each other. I can't remember the name of that. It's just a theorem. It's just like coefficient, polynomial coefficient theorem, something like that. And why is this? Unfortunately, you're going to have to watch another good few videos until we get to calculus, until I could give you a proof. But there is a proof, don't worry, it comes from calculus basically. Yeah, I don't think there's any worth showing you, but if you do know a little calculus, if we differentiate the left, we would, if we differentiate the left 3 times, we would get down to 6, 12, we'd get down to 12, a number 12 here equals 6 A's. You don't need to believe me, there'd be no X's though, there'd be no B's, no C's, no D's, and we'd actually be able to solve A. Again, using calculus going backwards a little, we could solve B, C, and D. We'd never be able to, we'd never be able to solve X in this question, as it happens. But the takeaway is simply this. Let me use different letters. What have we got here? We'll say gx cubed equals hx cubed. G equals h. Basically, any number in front of the x squares, x cubes on the left equal the numbers in front of the x cubes on the right. What that means here is 2 is equal to A. All the x cubes on the left, all the x cubes on the right. Again, minus 3 is equal to B. Now here's where you get a bit of trouble. Some of you might write some of you might write 3, first of all. The next bit is really tricky. Let's do the other side. Actually, let me write this. Let me write these again here. How about I write A is equal to 2? Makes a bit more sense. B is equal to minus 3. C. What does C equal? Ask yourself that. Pause if you need to. Think about it. What does C equal? D. D is a little easier. Oh, this is d to the power of x, 0. There's no x's there. 7 multiplied by x to the power 0. There's no x's there. So d is just equal to minus 7. All the numbers on the left, numbers on the right. So what the hell is c equal to? C is equal to 0. There is 0 x squared, there's 0 x to the power of 1s there. That's basically it. Like I said, I might do another class on this that in the future I could link in the comments proving this just from calculus. But for now, it's useful to maybe see. We're going to use this information, a lot of you will at least, from time to time. Coefficients on the left equal coefficients on the right. And I think that's it. Apologies if this class was a little boring or a little didn't get to the point of any of your questions. For the next 6 or 7 classes, we'll be doing the famous ones. Quadratic equations. Tune in then. And goodbye.